Picking up here, next lesson is section 5.8, and we're talking about constant and proportionality today. So this is notes pages 15 and 16. Constant and proportionality is going to be a key factor for us kind of moving forward here. We are looking at a couple different key concepts that we have here. So you can see those on your screen and also on the top of your notes packet there. So in a proportion, generally speaking, if one quantity increases, the other is also going to increase. Our constant proportionality that we're going to talk about today, we're going to call it crazy K because it takes on the variable K. And it's our unit rate. So really, we're just going to be doing division problems to calculate that unit rate. In particular, our division problems are going to take on the form y divided by x is what we're going to call them. So we might see a table where we have x and y values. We might see a table that goes up and down that has x and y values. And we're going to actually be doing division problems where we do y divided by our x values. If we are looking at a whole bunch of tables and we have all these different values, if we find the k value for each and every single set of data point and they're all equal to each other, the relationship is proportional. It gives us this equation y equals kx, and when we get here, this k in our equation is actually going to be replaced by a number. So let's jump into a couple examples and see what we can find out here. So example 1, a car technician took a car on 4 test drives. For each drive, the technician recorded the miles driven and the amount of gas used. In a table that's up and down, if it doesn't signal to you, x will be on the left, y will always be on the right. So to actually get k, we have to do y divided by x. So here our division problem is going to be 100 divided by 4, or you could write that as 100 over 4. Either one of those would be acceptable here. I'm going to suggest that you move towards this direction, 100 over 4, just to make your life a little easier moving forward. When we do that, we actually get 25, and that's our k value. So here we're going to again do y, 50 divided by x, which is 2. 50 divided by 2 is also 25. The next one, our y is 25, our x is 1, and we get 25. In the last one, we have 12 as our y divided by 0.5 as our x. When we get that, we actually get 24. You'll notice that all of these k values are the same, and then this one's different. What that tells me is that this relationship is not actually proportional. Down here underneath, there's a couple questions that actually follow. K represents our unit rate, so we can always give a unit rate our label. Y divided by x, miles per gallon, is our label here. So all of these represent 25 miles per gallon, and the final one represents 24 miles per gallon. So since the K values are not all the same, so that answer is no, this relationship is not proportional then. So let's try example number 2. We have a scientist recording data collected by a rover sent to Mars. The scientist recorded the time it took the rover to travel several different distances. In a chart like this, if they're not labeled, X is on the top, Y is on the bottom. So to get our K value here, we would be doing Y, which is 10, divided by 2, which is our X, and 10 divided by 2 gives us 5. In this one, we'd be doing 30 divided by 6, which also gives us 5. Here, y divided by x would look like 15 divided by 3, which will also give us 5. Here, we have 45 divided by 9, which is 5. And the final one, we have 20 divided by 4, which is 5. We can take a look at our label, our distance in centimeters per second. So we're talking centimeters per second is what we're looking at for k when we talk about our unit rate. Are all the k values the same? Yes. They were all equal to 5. So the relationship, yes, is proportional. Because all the k values are 5, overall in this relationship, k is 5. So our equation to represent this is y equals kx, but because all the k's are the same, we're going to actually erase k, and we're going to replace it with the number 5. So the equation that represents this relationship is y equals 5x. For example 3, we have another table here, x on the top, y on the bottom. We're looking for party favors. K represents our unit rate, which would be dollars per item. So dollars per item. Our job is to figure out, are all the k values the same? Is it proportional? And if so, write an equation. So we're going to be doing, for the first one, 5 divided by 10. 5 divided by 10 is going to be 0.5. 10 divided by 20 is also 0.5. 6 divided by 12, 0.5. 8 divided by 16 is 0.5. And 4 divided by 8 is 0.5. So the k-values are all the same, so it is proportional, and we can write the equation y equals kx, only replacing our k with the actual number that we found, that 0.5. Example 4, we have an x to a y chart. It's a diagram mapping. So we're going to go ahead and do y divided by x. We're moving backwards here. 3 divided by 9 is our first one. 3 divided by 9 is 1/3, or 0.3 repeating. The next one is 4 divided by 12. That also gives us 1/3. 5 divided by 15, which will give us 1/3. 6 divided by 18, which will give us 1/3. And 7 divided by 21, which also gives us 1/3. So all the k-values are the same. Yes, this is proportional, and our equation is y equals 1/3 x. And that's it for the first part of your constant proportionality, crazy K.